My name is Eli, and I am here to talk to you today about how we talk to each other. A bit about me: I have been a software engineer, did data engineering, got into developer relations, and now I mostly think about how to explain concepts to people. That's a big part of my job. I work as part of a research institute, teaching epidemiologists to write code, which is both easier and harder than it sounds. Please do come and talk to me about my work, because it's very cool. But this talk is about how the fundamental process of getting an idea out of one person's head and into another works, and what this means for us as people who are builders and testers and designers and maintainers of software. And there are various frameworks for thinking about this. I'm going to take you through some of those today. We'll look at some of them from historical philosophers of language. And I will start you off by explaining what I think is going on when I try and explain something to you. So here's two people, or here's me on the left with the pink head, and you are all of these people, and you've all got blue heads. And I have an idea, and I want you to also have this idea in your head. So I say something or do something. I make some sounds with my mouth, or I put down some symbols on a piece of paper or on a computer screen. This causes you to perceive those things that I have done. You hear some sound, or you see some shapes that are letters and things like that. And this gives rise to an idea in your head. And each of these four things is separate. They're related, but they are all separate. And of course, we can really complicate matters by this intermediate step going over a network or being delayed in time and things like that. And there are lots of complications that can happen at this stage. So we'll be abstract and not think about them. With this model, we have this idea of, we've got these four distinct things, and only some of them we can control. What's really interesting to me about this model is these translation layers, because there are translation layers happening in between each of these stages. The middle one can get degraded through things like being in a noisy room, or having to read a piece of paper that's been submerged in water, or whatever. All the different kinds of problems that can happen when we transmit information. But the translation layers in between me having an idea and me saying something, and you hearing something and then having an idea, those are much, much harder to understand. And that's what this talk is largely about. So we have these two ideas of we have these two concepts: having an idea in your head and doing something that symbolizes that idea. And if we want to understand the translation layer between those things so that we can better communicate with people, cause their light bulb to be as similar to our light bulb as possible, we need to understand the relationship between how we get from having an idea to saying or doing something that represents that idea. And it is now time for us to meet our first philosopher of the day, Ferdinand de Saussure. He was often called the father of semiotics, which is the field that I'm going to be largely talking about today. He was a very sort of influential seminal linguist. And yeah, he's one of the two major founders of the field of semiotics. So we come back to these ideas of a thing that you think and a thing that you say or do. Saussure gave these names. He said that this is the thing being signified, and what you do in order to signify that thing is you use a signifier. These are the mouthful words, and also words that are very easy to get confused with each other if I stumble over my words, which I do frequently. So I'm going to make a little update to Saussure's framework and say that this is the concept. Light bulb is the concept that's in my head, and the signifier are the words that I'm using to try and convey those concepts, right? And what Saussure said that was really quite groundbreaking for the time that he said it is that these two things don't necessarily have anything intrinsically to do with each other for a given concept, right? Which was groundbreaking at the time. People thought that the language that we use had some sort of intrinsic connection to the concepts they were meant to represent. And Saussure said, I don't think this is actually true. I think it's a lot more loosey-goosey than that. I don't think he used those exact words. But for example, let's take this animal. Now, who recognizes this animal? We all know what this animal is, I hope. And if you don't, you're one of today's lucky 10,000. But in various languages, this animal is called something like a meow, or something like that, right? I think ancient Egyptian has this as a word for cat, but in English it's cat. Why do we use those series of sounds to represent this animal? It's kind of arbitrary, but it works because we all agree that there is that connection, right? And it can get even more abstract than that. We can have very complex signifiers for fairly complex concepts, right? Does anybody here think that they don't know what any of these images means? Right? But why should this one particular, can I get a little light? Why should this particular image of a cartoon character's fist being clenched represent what it does? You know, why should this mean, oh, this is really awkward and I'm disappearing? Because we've collectively agreed that they have those meanings because they come from a context which gives them those meanings, and even when we take them out of that context, they retain those meanings. These are signifiers, and as long as we agree what they signify, they work as language, right? Or in other words, so if we come back to this idea of, you know, your 4 separate stages of communication, and we're looking at these translation layers, one thing that is not immediately apparent is that these 2 translation layers can't really be compared person to person. You know, it's really hard to articulate why I associate a particular signifier with a particular concept, or at least it is for anybody who hasn't spent hours obsessing over this kind of thing. It also means that 2 ideas in 2 people's heads, the pink light bulb and the blue one, can never be directly compared. There's that old sort of philosophical canard of, is the blue you see the same blue that I see? And I think this is fundamentally unanswerable, which also means that, you know, we're never going to have perfect communication necessarily, because how would you even verify that it happened? Ideas in people's heads are never going to be exactly equivalent because we don't even have a way to talk about what that would even mean. There are also more obvious ways in which ideas in people's heads could not match up even though we use the same words to describe them. So first time I gave this talk was in Porto, Portugal, and there is a Portuguese word that is famously claimed to be untranslatable. Do I have any Portuguese speakers in the room? Every now and then we get one. Even, you know, in Porto there were quite a few as it happens. So this word is famously called untranslatable, and it refers to a specific kind of emotion about that was experienced by people who were either on long voyages during the Age of Sail or who had left for the New World to colonize it. And the sense that this sort of bittersweet longing for home, even though they knew they were going off to do something that was worth doing, but they, you know, this is this sort of very complex feeling. And you can see that in order to explain this word, I'm having to use a lot of words in English. It's one in Portuguese, right? And part of the reason that it's so difficult to explain these things is because we don't have the cultural context that the people who coined this word and used this word did. And so we don't have the same internal experience that this word, I don't have the equivalent of that light bulb in me. I haven't felt that, I don't know it. And so we have to use a lot more words to sort of try and evoke it in somebody. If we come back to this idea of these concepts and signifiers, we need to understand the relationship between them. And Saussure says, okay, this is, we have these 2 things, and obviously once everybody agrees that a certain signifier refers to a certain concept, we can use it to communicate. But how do we give rise to these relationships in the first place? Where did they come from? How do we get from, we can go one way, but how do we go the other way? How do we learn what signifiers relate to which concepts when we don't already know? So Saussure came up with an idea. He said, okay, here's somebody with an idea in their head, and they say something that signifies that idea. They know how to do that because they have an act of parole, meaning speech. How do they know how to make a speech act? How do they know how to translate the light bulb into the sounds or the words or whatever? He said, okay, they have this idea of something called the langue, which is the sort of collectively agreed upon translations, like, you know, for this is how we refer to these concepts. And when linguists study, largely this is what they're studying, this idea of the langue, this collectively held consensus of how we denote concepts with signifiers. But all we've done is kick the can down the road one step by defining this, like where did the langue come from? Saussure said, okay, it's defined by usage. We have language as a thing that both defines and is defined by its own usage. If you make speech acts often enough and they get enough uptake, they become part of the langue. They become part of the agreed upon consensus. And we can see this with memes. You know, we started using them to refer to these things. You know, this image of Steve Buscemi being like, how do you do, fellow kids, hasn't always existed as part of our collective understanding of language. It became part of it through usage gradually over time. And this was another thing that was revolutionary that Saussure said at the time that he was writing. This is called his speech circuit. And his thesis statement here was that this is a sort of circular, ever-evolving thing. And this is what gives rise to the changes in language, and whether or not there are sort of blockages or different rates at which certain people move through certain parts of the circuit will give rise to differences in vocabulary across different communities, things like this. This is, if you don't regularly use a particular piece of slang as part of your parole, it's not going to be as strong an idea in your langue. But we all have to have an agreement between us of what the langue constitutes in order to be able to communicate effectively. So we come to this idea of the langue as this collectively held idea of how to translate concepts into signifiers, a sort of shared dictionary, which exists in all of our heads, but not exclusively in any one of our heads. It only exists as an emergent property of people communicating with each other. And somebody who did a lot of thinking about how this actually works in practice and how we actually could see the idea of this manifesting is, to me, it's the guy who was like the philosopher, Ludwig Wittgenstein. Have we got any Wittgenstein heads in the audience? Anybody know? Has anyone heard of this guy? You've heard of him. You've heard of him? All right. Well, the rest of you get to meet Ludwig Wittgenstein today. He was quite a character. He did everything basically in terms of philosophy. He did logic. He did maths. He did language, and he had interesting things to say about all of them. I don't necessarily agree with all of the things he said, but he was an incredibly sort of influential philosopher. And one of the things he did was come up with the concept of language games, for which this talk is named. And he coined the idea of language games as a way to demonstrate the relationship between concepts and signifiers. He argued that language and communication is like a game of skill or luck or any of these other these things, in that it has rules, and the rules can be violated. And in order to play a successful game, you need to abide by the rules. He used a lot of kind of analogies and sort of abstract language to describe this concept, because it's difficult to describe succinctly in the abstract. He used a lot of examples, so I will do the same. So let's say we have these things that people are building something out of. And let's say we have two people, let's call them Chris and Art, and they are doing some Lego together. And in order to, Chris is building and Art is passing him pieces. And in order for Art to know that Chris wants him to pass one of these pieces, Chris says, block. In order for Art to know that Chris says he wants him to pass one of these pieces, Chris will say, plate. And for one of these pieces, Chris will say, jumper, right? This is a very rudimentary language game. Saying jumper means, please pass me one and exactly one of the things that look like this, but, condensed down. That's it's like a command. And as long as you people playing the language game understand the rules, you can use communication effectively to achieve a goal, collaborative communication. Now, it's worth noting in this language game, very rudimentary language game example, that it would have been more efficient for Chris to say pink, white, and blue rather than jumper, block, and plate, because pink has one fewer syllable than jumper, right? But, because they're Lego nerds, they want to use the correct terminology for each of these Lego elements, right? Language is not strictly about efficiency. It has cultural context bound into it. It has sort of human quirks, for example. But that's a very rudimentary example of a language game. So there are some rules that have been set up, and by making legal moves, we can progress the game and share knowledge and understanding. So if language is like a game, what does it mean to break the rules? Can anyone tell me what this sentence means? I'll give you a moment. Anyone want to venture a guess? It's nothing, it's meaningless. It violates the rules of language. The specific violation that this one poses is something called a comparative illusion. You're comparing a quantity to a bool, essentially. And we don't have, in English, we don't have casting bools to 1 or 0, right? We can't do that. You're comparing two things that are not of comparable types. But it scans like reasonable English. So you look at this and you go, huh? This is an example of breaking the rules of English. It doesn't convey any meaning. It's a nothingness. It's no statement. No information is being conveyed here. On the other hand, we can break the rules, but we can also augment them. Does anyone know what this means? Any guesses? Would it help you if I told you that this is the baby? Any guesses now? Yep. We need to trim our cat's claws. This is Gothmog. She is the baby of our household. She sometimes gets quite sharp, and so we need to unsharpen her. Gothmog's nail trimming time, we need to unsharpen the baby. And because I can, I'm going to show you another photo of my cat, because she's the best. And the reason this works as an example of a valid move of the language game of my household, is because we've set house rules, right? Context, additional context, sets rules for a language game. So in order for Chris and Art to play their Lego game, they first needed to agree on the rules of what jumper and block and plate meant. And if they have the shared context of being Lego nerds, they will already have that shared understanding. In my household, knowing that the baby refers to the cat means that things referring to the baby suddenly become intelligible when they weren't before. And this is essentially Wittgenstein's big thesis statement that he was making that, again, was radical for his time. He said that context gives communication meaning. Language doesn't mean anything without shared context within which it sits. And this was, again, coming back to that idea that the signifiers we use have some intrinsic magical connection to the concept. This is in violation of that idea, and so it was radical at the time. If we come back to the idea of saudade, this allows us to think more about why this can sometimes be a difficult move to make in a language game. Because if I don't share the same context as to the specific kind of bittersweet longing that's formed part of my cultural history, I perhaps can never feel this emotion because of not having that shared context. And that's a thornier philosophical question than I'm capable of answering. But it's an example of the fact that having extra context makes language act differently on you. It makes that translation layer between what you hear and what you think unique to you, your own unique context. And the more context we share with other people, the more effectively we'll be able to communicate with them, or the more efficiently we'll be able to communicate with them. So if language works because we share context, what would it look like if we had to communicate with people with whom we did not share any context at all, or very minimal context? And there is an institute that has this essentially as a kind of mandate, and it is the Institute for Long-Term Nuclear Waste Storage. Does anyone recognize this phrase? So this is the first in a series of messages that is designed to be, it's not designed to be necessarily written on facilities that store nuclear waste long term, because context, we do a lot of cool science as a species, and as a result we make a lot of problems for ourselves. One of them is the existence of harmful materials that will continue to be harmful on the order of tens of thousands of years, longer than any one human civilization has ever lasted, arguably, but like longer than certainly most human civilizations have ever lasted, longer than any one known language has continued without significant change to it. And so what we have a problem is, as people who are generating nuclear waste now, we have a mandate, we have a responsibility to let people in the far future, continuing forwards into the future, know that you shouldn't mess with this stuff, it's bad for you. And so there's this series of messages that were designed by this institute, things like, this is not a place of honor, no great deed is commemorated here, like, the danger here is present in your time as it was in ours, and the danger is to the body, and all sorts of like really metal sounding stuff. It's so cool, honestly, I so encourage people to go and read up on this thing, because it's really, really cool. And the idea is not that we would necessarily write these words down, because language might change over the course of the time that we are responsible for protecting people from this stuff. These are as close as we can get to, these are meant to represent concepts. These are trying to be very bare signifiers, right? We want to convey what this means somehow. And these series of messages that were designed go from something very broad, this is not a place of honor, don't, stay away, to very specific things like, the danger here is to your body. How do you explain ionizing radiation to somebody that you don't know has a similar understanding of physics to you? You don't know what language they use. And so this is a very difficult problem that this institute has to tackle. And they've got, linguists and philosophers and, nuclear physicists, I think, as part of it. But largely it is a problem of communication. And one of the things that they have developed that I think is really interesting is this symbol. This is ISO 21482 2007, made in 2007. And this is a proposed sign that they think we could put on nuclear waste management facilities. And so it's this triangular sign. And if we look at each of the elements, we can kind of see some of the reasoning that's gone into this. So first we have skull and crossbones. This is universally, currently, bad. Danger, you will die. And there's good reason to think that this would still have that meaning to people in the far future. As a species, we don't typically see our own skeletons. We bury our dead. We don't tend to keep them around until they become skeletons. Generally, if you see a skull, something has gone terribly, terribly wrong, right? This is a fairly, we hope this would continue to be a fairly universal symbol of bad things will happen to your physical form, right? So here it is on the symbol, on the sign. Now we next have this. We can think that, we can probably assume that humans in 10, 20,000 years will have the same sort of body map as us. Evolution doesn't work fast enough to give us, extra limbs in that time, no matter how close you might be living to the nuclear waste facility. And we can hope that this would be recognizable as a person in motion. And we hope that the arrow would still, have the same connotations. But we can't be sure, right? Maybe that arrow would not mean the same thing to people in the future. We just don't know. But it's a reasonable guess. And lastly, we have ionizing radiation, which is an incredibly abstract concept that you're going to try and communicate to people with whom you don't know if you share any context. So we have the atomic sort of symbol there at the top, and then these wiggly lines that are meant to represent rays of danger. This is the weakest part of this, I think, and it's for good reason. It's because a lot of context is needed to understand the very abstract concept to which it refers, something which we don't really have physical representations of in the same way that we do a skull, right? And taken all together, we can understand why this would represent to us today. There's atomic danger that's emanating out. It's very bad. You should leave. But as my friend Dylan pointed out, this could also mean when snakes come out of the ceiling fan, run away from the pirates. Communication it's never perfect. And the more context we share, the closer we can get to good enough. And the less context we share, the harder we're going to have to work, the more approaches we're going to have to try. Another approach that I'm not sure if it was made by this institute, but it's somebody came up with an idea for warning people about nuclear radiation in the far future. And it's based on two things that have been largely true of humans for a long, long time. One is that we like to hang out with these animals, right? We have a mutualistic relationship with these animals as an agricultural species. These animals hang out in our grain silos and eat the mice that come and eat our grain, right? And we like them, they're cuddly and cute, and people keep them in their house for fun, like me. So we can reasonably expect that humans will continue having cats in their lives. Cats will come, will naturally happen where human civilization happens. We also now have the ability, through science, to genetically modify cats such that they glow in the presence of ionizing radiation, which is extremely cool. The idea is we introduce this gene into feral cat populations, and the populations of cats from which our random bred house cats come as well. And we hope that people will see their cats start to glow and go, ooh, something's a bit weird here, something's wrong. But maybe they'll just think that the cats are cool and glowing is really nice and that's fine. So we need some other way of conveying through generations that when your cat glows, it's bad. And one of the ways that humans have traditionally passed down knowledge is through oral tradition, and specifically singing tradition. So this guy wrote a song called Don't Change Colour, Kitty, which is supposed to be incredibly catchy. I have not listened to it for fear that it will never leave my head. It's supposed to be an incredibly catchy tune, and it's all about how if your cat changes colour, that's bad and you should leave. That sort of very abstract idea. He's not trying to convey why. It's just trying to get the actual operational thing of, if your cat changes color, you should leave, to try and protect these hypothetical human populations from living somewhere where there's enough ionizing radiation to make their cats go. So with these two sort of things, like humans like cats and humans like music, and we obviously all know the ability of music to carry an enduring cultural message, right? Yep. My water break. Right, so that's how communication works, right? It's never going to be perfect, but we can understand it as trying to link ideas to actions, sounds, shapes, and hoping that those shapes get transmitted to somebody who's going to perceive them, those acts get transmitted to somebody who's going to perceive them, and that their perception gives rise to a similarly shaped light bulb in their head. Everyone with me? Cool, we've got some similarly shaped light bulbs. We come back to this model. What does this mean for us as people who work with computers? Well, this is what happens when you write code, right? Is you have an idea in your head, and you write some code, and then it gets executed on the computer. And one of the things that I hypothesize is one of the reasons that we have such a high rate of neurodivergence within people who like to code is that this takes a lot of the ambiguity out of the whole situation, right? If I write a hello world thing and I know it's correct and the computer does it, I can verify that I have correctly, successfully communicated my idea, right? And the computer doesn't have interiority. So there's no room for misunderstanding what the computer has done as a result of the code that I gave it. You know, we can look at how C is implemented, for example, and then Python on top of that, for example. You know, we can look all the way down the stack and know that what we did as an act of communication, writing the code, has had the desired effect. And if we think about this in the context of language games, programming languages are sets of rules for a language game. Through, like, starting from, you know, our ones and zeros, our machine code, we can build up, like, syntactic sugar on top of syntactic sugar until we have something that is language-like enough to be called a programming language. And what we've done is we've iteratively added rules to the language game so that curly braces means something now. Now, like, def something, you can tell I'm a Python person, means this. And when we speak different languages, it's because we're using different rules to talk to the computer, essentially. But it goes beyond that, because what we're actually doing when we write software is we're actually adding more rules. When I write a class definition for user, I'm teaching the computer what it means when I write user, right? I'm giving it extra rules so that I don't have to write everything out long form. That's what we're doing when we define functions and variables. We're adding more and more ways to more effectively communicate with our computer, with the software that's going to actually execute, by giving it more context about our business problems. We're trying to fit our business problems into the computer by giving it the context of them, writing code. So when we're writing code, brilliant, sorted. Like, as long as you can reason about what it is that you want to do and write it in code, you can do it. And this half of the equation is solved. As I said before, you can look at how your code, like, compiles. You can verify its correctness if you really, really want to. And a lot of the work of getting good at writing code is on this side, being able to reason about the idea and accurately translate it into an act of a parole, like writing code. One thing as a slight aside, because we are now in the age of generative AI, if this half becomes non-deterministic, that does actually fundamentally change the landscape of what happens when you write code. So if, for example, as part of my software running, there's some model that's non-deterministic, suddenly I lose the fact that this is a solved half of the equation. And suddenly you introduce that problem of, have I communicated correctly? Is this doing what I think it's doing, back into the equation? Which is not an angle that I see many people talk about. And I don't have much to say about it other than, like, I think that's an interesting point to make about non-determinism in software. But by and large, that's when you write code. It's great, we love it. Everyone loves writing their little hobby projects, and, you know, the moment when you get the computer to do what you wanted it to do, you go, yes. But when we write software in a team, it's not just us, is it? There's me writing my code, and there's my colleague writing their code, maybe my many colleagues writing their code. And we are both trying to communicate with the computer at once. So we better make sure that we are sharing enough context with each other that we don't confuse the computer about what it's supposed to do. We all need to be playing the same language game. And this is why we also talk to each other as humans when we write code together. You can do it without, like this line at the top is a valid sort of path of communicating with each other. David Whitney has an excellent talk about intentionality in code and code as literature that's primarily intended to be read by other humans, and it's incidentally executable by a computer, which is a fantastic talk, and I highly recommend it. This is a valid communication pathway between two humans as well as with the computer, and some open source software development communities use this as very heavily as a method of communication. But this line also is things like code reviews, it's water cooler chit chat, and so on. So this is what's happening when we write software in a team. And while there's still there's extra complexity here, we have by and large, as an industry, got quite good at this. We've got our processes down for making sure that we're aligned on code and that the code works as we expect and that we write tests so that we can verify that our communication has been successful. And when we build software together, we use code to communicate in addition to other means. And those additions to those other means, meetings, GitHub tickets, GitHub issues, all of these things, we come to think of as our primary method of communication with other people, but code is also there. And there are things we can do to make our code a more effective tool of communication between us when we write software. I would like to introduce us to our third philosopher of the day. This is Paul Grice. He was an English philosopher of language, and he came up with something that's called the theory of the cooperative principle, but it's more commonly known as Grice's maxims. Has anyone heard of those before? Right, yes, spreading the word. So he came up with, and these were descriptive things that he noticed. He observed a lot of people doing what he called cooperative communication. And cooperative communication is multiple parties making a good faith attempt to simply maximize information transfer. There's no lying, there's no joking, there's no misdirection. You are just earnestly trying to communicate as effectively as possible. And he noticed several traits cropping up again and again in examples of this kind of communication. And he gave them names, now his maxims. Maxim of quantity. And these are often stated prescriptively, you should do this, but he noticed them as descriptive things. He noticed that people tend to be as informative as required, but not more, for maximum efficiency in transferring information. Maxim of truth, only say things that you can reasonably assume to be true. I'm not misdirecting you for the purpose of a joke. I'm not lying to you for whatever reason. I am simply earnestly trying to say things that I think are true. Maxim of relevance, don't include things that are not relevant. When you're trying to communicate about one thing, don't start talking about another. Some of us have ADHD, that's hard. So, maxim of clarity is the one that I think is really, really interesting. Avoiding ambiguity and obscure language, presenting your message in a way that is easy to understand. The other three are you can reason about them in a fairly cold, logical way, right? The clarity one is specifically about communicating with other people, right? Because this is the part where you are trying to formulate your communication in a way that's going to be digestible to the translation layer that the other person has that takes acts to ideas, right? What you should do in order to obey this maxim as best possible is to try and think about your audience, who are you communicating to, and formulate your attempt at communication in such a way that it's going to slot neatly into the way that they think, their idea of the long, their idea that, try and play by their language game's rules. And to do that, you need to understand them a little bit more than you do, you need to understand them. You need to understand their context. And that's what makes that the really thorny one and where the bulk of communication issues tend to crop up. So, actionable takeaways, because every conference talk should have actionable takeaways. When it comes to these four maxims, they have a lot of good advice for writing code. Maxim of quantity, be as informative as required, but not more. Don't include extra stuff in your functions that you don't need to and things like that. Write code comments that help clarify, but don't write code comments just for the sake of writing them, things like that. Use type hinting in your Python if it adds information, but don't do it just to do it. Maxim of truth, only say things you believe to be true. Validating your assumptions when you at the top of a function, make sure that you didn't accidentally pass in something null when it wasn't supposed to be, things like that. Maxim of relevance, don't include information you don't know to be relevant. In terms of code, this looks like making sure that you only actually take in the inputs that you need and you don't end up passing loads of cruft that could cause your code to be brittle and break down later because something changed, but it wasn't actually load bearing, but the tests broke because you included it anyway. But a lot of what I would like to talk about for the rest of this talk comes from this one, the maxim of clarity. Because what does this mean when we apply it to code? Avoid ambiguity in your code, avoid obscure language. This can mean things like, writing clean and well-documented code, avoiding cleverness, avoiding the neat one-liner, focusing on readability instead, designing your code to be easily understandable by another human, not just the computer. But the last bit is the bit that I think is really interesting. Matching your code structure to the structure of the problem it solves. This helps your code be more clear. If you understand your business problem and you are phrasing things in the language of your business problem, the problem that you're actually trying to solve, your code is going to be easier to understand for other people who share that context, which should be all the people in your organization that you're working together with to build software. And the reason this is particularly relevant is because this is what happens when we're building software on a team, right? But we're rarely just building software on a team. We have stakeholders. Yay, stakeholders, people who tell us what it is that we need to build. And they say something, they say we need the software to do this feature because our investors say we need it, or because we've had user feedback that we need it for whatever reason. We need to do something to our software. And that means that the developers hear something, maybe it's Jira tickets made by their project manager or whatever, product manager rather. And that means that developers have an idea of what they need to do to their software and they go away and implement it using teams of softwares, the processes that we have developed and got good at over the last few decades as software engineers for turning ideas into software. And this part of it, this is where a lot of things go wrong, right? Is the communication between the people who pay our bills and the people who actually make the things that build the software. And when these kind of communication problems happen, it can lead to problems from ranging anywhere from, they don't, sorry, tripping over words, not having consistent ideas of how long something is going to take to build, right? Which is an annoying problem, but not the worst thing in the world. But a bad problem that can happen with this is stakeholders ask for something that requires you to completely rewrite your project. Let's say you've built some kind of billing software and suddenly your stakeholders come to you and they say, well, we need to be able to issue refunds in a different currency than the one that person originally paid in. And you have, whatever back end you have built fundamentally does not allow that to exist. You would have to rewrite your software from scratch. The move that they are asking you to make breaks the rules of the language game that you have created with the computer in the software that you've already built. And you would have to strip down all your house rules back to ground zero, which is your programming language and its standard library, and rebuild to allow you to create a language that lets you say, refund this person in a different currency than they paid in. Has anyone ever had that problem where a feature that you've been asked to build was just simply not possible? You'd have to basically rewrite the whole thing? Yep. It happens, and it's really, really frustrating when it does. And occasionally there are workarounds, but they'll, if you, as we all know, you put one bodge on top of another and suddenly you've got a whole mess. And so getting this communication right, making sure that what you do as a software developer is setting you up to be able to communicate with your stakeholders in their language, using the rules of their, the business problem is the language that they speak, making sure that your software matches what the business problem is, allows you to stay in lockstep much more easily with the people who are speaking that language and pay your bills. Now, of course, this is what's happening when we are in a company and we have stakeholders or an institute, and we have stakeholders who say, this is what we need to build, and you go away and build it. This is what I think is actually happening, but I'm not a stakeholder. What stakeholders think is happening is this. I'm a stakeholder and I have an idea on my head, and I say something, and then the software appears, right? And we're just an implementation detail in that. We are just the mechanism by which their act of speech becomes software. And if we think about this model, what we should be doing is trying to make our lives as easy as possible as people who need to translate between what's in the stakeholder's head and what the computer thinks about the business, how the computer is able to conceptualize of the business problem. I'm trying not to use anthropomorphic language for the computer so much, because again, it doesn't have interiority, but we want to be able to articulate the things that our stakeholders say to us in the language of the software that we have built, to allow the stakeholder to effectively do what to tell us what the software needs to be. And there are various tools that have been built to kind of address this problem, things like gherkin tests, like I'm trying to remember the gherkin syntax. Has anyone used that before? Where you write tests that are sort of, or the use cases like plain language. Yeah.
BDD.
BDD, yes, behavior-driven development. Yeah, you let your stakeholders essentially write tests, which are the spec, and once the test passed, you're good. These have had limited success because stakeholders don't tend to like thinking in formal language unless they have already been developers, which not all of them have, to our great chagrin. And no matter how sort of nice the BDD syntax looks, it is still formal language, and it does still constrict people. So there's always going to have to be a little bit of human messiness in there. But what we need to do, I think, in order to make this translation as easy as possible, is basically what domain-driven design is. Has anyone here been listening to me talk and think, oh, it's domain-driven design that they're describing? No? Yeah? Yeah. This is what domain-driven design is. It's matching your code structure and the way that your software is sort of logically built to match the real-life problem that it actually describes. What it's doing is, taking business concepts and then making those be the code concepts as closely as you can, and trying to make your abstractions match the real world as closely as possible. And that means that the people who think about the business problem all day, talk about the business problem all day, want you to build software that solves that business problem, that you all speak the same language. You're all playing by the same set of rules for your language game, not only in terms of what you, the developer, understand about the business problem, but in terms of the way that you have described it in your software. What this does is lessen the burden, the cognitive burden on you as a developer in translating what it is your stakeholders want to what it is you have to write as code. Because if your stakeholders mean one thing when they say user, and your code has 17 different definitions of user and none of them quite match, you're going to have a bad time. Unfortunately, what this means is a lot of upfront conversations, talking to humans, making sure that you're all on the same page. But we already covered that. We know how that works. We've got our concepts and our signifiers, and we know how to agree on terms so that we're all speaking the same language. For example, talking to your stakeholders and saying, okay, what do you mean when you say user? And you end up asking a lot of questions that sound really stupid, but they are so necessary because it's so easy to not realize that you're not speaking the same language, even when you're both speaking English. So, what are the sort of actionable takeaways in terms of domain-driven design? Well, the main actionable takeaway is go away and read up on domain-driven design, listen to some talks from some excellent speakers. We have some experts here today. This week at this conference, Ian Cooper is one of them. So if you get a chance to talk to him, highly recommend picking his brain. I think domain-driven design arises very naturally out of these sort of frameworks about communication, and the way that I argue they apply to us as people who talk to computers as well as other people. But in short, we want to reuse context as much as possible. We want to understand what it is that our stakeholders mean when they say something, and just lift that context wholesale and make that be what we do with a computer as well. We want to all play the same language game, mean the same thing when we say user. We don't want to have to spend effort in translating what it is that our stakeholders want into what we have to do to the computer in order to make them happy. And having our signifiers match our concepts. Yeah, as closely as possible, because again, it will never be perfect, especially when you're communicating between two humans. But we do all right as a species, actually, at this, given that it's fundamentally a problem that we can never actually solve. My light bulb will never be the same as your light bulb, and to say that they are is a meaningless statement. But we can do well enough to build software that works, build software that's satisfying, and have conversations with each other that leave us both richer in information for having had them. The conclusions. Computers are awesome. We can communicate with computers in a way that we can't with other people, because we can actually know that we've managed to communicate something to them correctly. That's what code is, and that's what code does when it's deterministic, at least. Communication is hard. It is fundamentally impossible to do correctly. If you argue that correctly is about having our light bulbs be the same thing, because they're not comparable. But through practice and through thinking about it rigorously, we can get better at it. And the ideas that I've sort of arrived at and that I've tried to share as part of this talk can help you in all areas of your life. Obviously work, but also in terms of just talking to other people and having a better idea of what happens when things go wrong. Being able to diagnose problems that you thought might have been about intent or understanding, and realizing that they were really about communication and making sure that what you are saying is landing the way that you want it to. That's the thesis statement. Is communication is hard, but we can get better at it, and hopefully some of what I've shared today will help you do that. Thank you very much for your time and attention. And also, yes, before we clap, on Friday night, if anyone's sticking around, there is an event that we are running, that some of our NDC speakers are running, PubConf and the Line Breakers. PubConf is going to be lots of NDC speakers doing funny talks, funny songs, and in between those, we're going to have 2 sets of the Line Breakers, which is the band that I and some other speakers are part of, and we take rock songs, pop songs, cover them and turn them into software, talking about software. It's really, really good fun. It's more, if you're thinking that sounds good, it's better. So if anyone's around and would like to do that, we're at Slaughtered Lamb over in Clerkenwell. There are some tickets left. That QR code will take you to the page for it. And I hope to see you all there. And I hope that this talk has been useful, interesting, and that you are ready for 2 more excellent days of NDC. Thank you so much.